Hello guys, this is Karim Hamdi, and today I'm going to be doing a tutorial on doing a temperature station with the ESP32. But it's not a regular temperature station where you basically take the analog signal from the temperature through the ADC of the microcontroller and then broadcast it to your serial bus to the PC. We're going to be doing that, but we're also going to be broadcasting this information to the cloud, to the internet, using the Ubidots IoT cloud services. As you can see right now, I have connected the ESP to my laptop through the USB, and this is just a serial terminal. And right now the ESP is broadcasting the temperature. It's about 20 Celsius degrees, which is really cold. Anyway, we are broadcasting this information to my Ubidots account. First of all, if you're not familiar, this is the ESP32 development kit that we are using right now. It's based on ESP32 IC, which has many variants, and basically any one of them could work with us. Okay, so what is Ubidots? Ubidots is an IoT cloud services platform that basically makes it really easy for you to send your data to the cloud without having to deal with all the hassle of the servers and the hassle of the connections and settings and all that stuff. You basically send the information to the cloud, and with just a few clicks of a button you can have a really awesome and informative dashboard just like this one. So this is the Ubidots platform. Okay, it has a bunch of features. First of all, it's really easy to make this kind of dashboards with just a few clicks of a button. It doesn't really take a web development expert to make these kinds of dashboards. Second of all, it's customizable to your application or to your company or to your product. You can have all the features of the Ubidots platform without really showing that it's backed up by Ubidots. So it can be really customizable for your company and for your products. So we're going to be using this platform in this tutorial. It's really easy to start with Ubidots. You can just sign up your account, and then you're going to have a tutorial that's going to take you step by step to hook on to your device. It's free, of course. You can start working with it right now. Moving on, what are we going to do in this tutorial? Our goal is to broadcast this information to the cloud, which is this device. We're going to be doing that right now. So that's what we are doing right now, is that there are new data that's being broadcasted right now. As you can see, this is the same data that's going to be broadcasted from here. If I set this to 1 minute, you can see that this is the information that we are looking for. This is 1 minute, and this is 1 hour. Yes, this is 1 hour. Okay, this is the name of the variable that we are sending to, and this is the if I make the API credentials, and this is the default token, and this is the API key that we are using to communicate from the device back to the application. And basically what you're gonna need, all are you gonna need is that those three variables, the temperature or the variable name and the credentials, basically the token and the API key, those three pieces of information. This is all you're gonna need to connect your device with the cloud, basically, and have these awesome dashboards. Just two things to take note of. There is a Ubidots for education. That's what we are using right now, and there is a Ubidots for industrial applications. That's the more driven to the industry and for your solutions and customizing this to your solution. So make sure that you're logging into your educational Ubidots account, not the industrial, because if you just hook on Ubidots and then log in, you're gonna be directed to industrial, and this is not what we want. We want the educational Ubidots. Okay, moving on. So this is the Ubidots platform that we're going to be using. We're also going to be using ESP, but you might be familiar with the ESP, but what is this rest of the web page? We are using a really awesome and powerful set of tools, basically the Zeroth tools. Zeroth basically makes a lot of tools and a lot of utilities for developers to enable you to develop really good IoT solutions, really easy IoT solutions, just like the one that we are doing right now, and B, to make it really easy to use Python and C. You can use the high-level functionality of the Python and the easiness of Python, while also developing your applications in C and utilizing the powerful the power of C programming language. So basically, it's a really awesome middleware tools for you. Basically, Zerenth makes a studio that's we're going to be using today. We're going to use the Zerenth Studio to develop this application for the ESP. The Zerenth virtual machine is basically the software that's going to be installed on your ESP. And the advanced device manager and the Zerenth app is just another tools for you to make really better applications, but we're not going to be dealing with them today. Anyway, so this is Zerenth. If you want to get started, there is everything that you're going to need on the web page. Basically, already thing to note is that in their documentation, there is getting started in the documentation. This is really enough for you to just get on and start with Zerenth, and everything's gonna go step by step for you to develop your first Zerenth project.
Hey guys, so this is the ESP32 development kit version 1, which is based on the ESP32W Room 32 IC, and the schematics and the hardware is actually fairly simple. You're gonna need a ground. This is the ground pin, and this is the A4 pin, the fourth pin of the analog pins. If you wanna know the pin diagram of this board according to Zerenth IDE, you can check that on the pin map in the IDE of Zerenth. And moving on to the sensor, actually the sensor uses a 5-volt input VCC, which is provided by this red wire, and then of course it has a ground for the 5-volt source, and it has to be a common ground of course with the ESP, so it's hooked on the same ground to the ESP. And then the analog pin is registering the variation of the signal on the middle pin of the sensors. So basically the sensor, this kind of sensor, the LM35, so this kind of sensor uses the 5-volt pin on the left pin, and then the output voltage that's going to be fed back to the microcontroller on the ADC module on the middle pin, and then the rightmost pin is going to be the ground, which has to be of course a common ground between the ESP development kit and the sensor. I'm doing this kind of setup because the ESP, this development kit doesn't have a 5-volt output. If it does have a 5-volt output, then it's just going to be a 5-volt output from this to this, and it's ground back to the board, and then the ADC in the middle pin, and that's it. Alright, now we're going to connect the board. We're going to connect the board to the laptop.
Hey guys, so this is the Zerenth IDE integrated development environment. Right now I have connected the ESP32 to my USB to my laptop, and then as I can see that the device has been identified, I can register it and virtualize it. This is you have to register each device that you use on Zerenth, and you have to virtualize the device with the appropriate software to gain access to this awesome features of Zerenth. So right now we are using a library support for Ubidots. So why is it that good? Because it really makes you focus more on your development of devices and products, and it deals with all the hassle of the HTTP requests and the server side and that stuff. So with just a couple of lines like device and connect and variable update and publish, you are basically online and you are hooking your device to this IoT platform and many other platforms. This makes it easier for you to focus on the important stuff of your products and the important stuff of your development, rather than focusing on the connections and requests and parsing of the data and that stuff. So this is the code that we're gonna implement on the ESP. A couple of things to note is that the project consists of mainly a Python file. That's why we are using actually Zerenth. It's because Zerenth gives you the ability to code in Python side by side with your coding in C. First step is connect the ESP32 to your laptop. That's what we have done right now. And then if this is your first time using Zerenth or using this device, you have to create a virtual machine and then you have to virtualize it again. For a step-by-step guide for that stuff, you can look at the getting started in the documentation of Zerenth. It goes step by step on registering your device and then virtualizing it. Everything is there for you at the documentation. So the documentation, actually there is an installation guide if you haven't installed Zerenth yet, and then there is the getting started, where it would land you eventually on having your first project, uplinking a Zerenth project and then having your first project. Anyways, so this is what we have done. I've just virtualized the device. So right now I'm gonna clone the example. I'm gonna search for Ubidots example, and then I'm gonna clone it. Gonna say Ubidots tutorial, and the project is being created. Okay, so right now we have cloned the project. Right now we have created the project. A couple of things to note is that we have a main Python file which has the code that's going to be uploaded to the device, and then we have a JSON file that has the information of the Ubidots account. It is either educational or industrial. This is the name of the device label, which is right here, the name of the device label, and then those credentials, API keys and tokens has to go right here in the API token. Okay, so we have to copy our code and then replace our code with this code right here. This is what I've done. Let me just open my project. So this is my project. And then I have altered I have put my credentials in here. So all in all, to keep it short and simple, project, you have to modify two things. You have to modify your Ubidots account information right here. So this is gonna be my device label, and this the API token ZM4. This is the API token, and then you have to modify the Wi-Fi credentials right here. Other than that, you just have to connect your sensor to A4. I have hooked it to A4, but you're gonna ask me which pin is A4. You can look for it at the pin diagram right here. This is the A4. So everything that's gonna be done on Zerenth has to go with the appropriate input-output pins and peripherals pins. So you have to look for it in the pin map. This is the pin map. And when you're done, you can just compile this. It's being compiled, and then you can upload this to your device. It's being uploaded. Then you can open the serial terminal, which is this button. This is the name of the device, and then the USB 0. I'm gonna reset the device. The device has been reset, and then it's going to connect to the Wi-Fi, connecting to Wi-Fi, connected, and then connected to MQTT broker, which is linked to your Ubidots account, and then we are sending to our Ubidots account. You can check for it. can check for your data. This is the data that's being sent right now. Okay, as you can see, this is the data that's being sent right now. Okay, so let me just explain what is the code, what does the code consist of, and what does it do. First of all, we are importing the analog digital converter library for this microcontroller, the ESP32. Streams is the serial library for Python, and for Zerenth, JSON, JavaScript object notation, something that we have to use to get the information. This is the Wi-Fi driver, and this is the Ubidots library. We're configuring a new resource that is device.configuration.json. That's the one we are using right now. So basically, we're telling the compiler that, hey, there's another file that we would use that's called device.configuration.json file. This is a function. We're gonna get to that later. Initializing the serial stream, initializing the Wi-Fi driver, connecting to the Wi-Fi. This is the name of my SSID. This is the name of my Wi-Fi connection, and this is the password. I hope that you're not in my neighborhood, really. Anyway, so this is my Wi-Fi credentials. Just a bunch of initializations, and then we are trying to connecting to device label. So where is this device label? It's in this JSON file. We are trying to connect to this device, which is this device. We're trying to connect to ESP32, which is this device, with this API token, which is linked to our account right here. This is the API token that we are talking about. So right now, after we have connected to the API token, just connect, and then we're printing that we have connected to the API token. The last thing is to send the appropriate data to the appropriate variable. That's what we are using right now, is that we are sending temperature Celsius, whatever data that it holds, to that variable called temperature. All we have to do right now is just calculate the temperature. Right now I'm connecting the A4 pin to the output pin of the temperature sensor, and then I'm doing just a bunch of calibration and calculations on the data, and then I am printing the data serially, and then I'm broadcasting it to the variable temperature. The variable temperature is the same temperature that we are looking at right now. This is the variable temperature. A device may consist of a lot of variables. This is for your information. Right now, this project does two things. It broadcasts the temperature or the value from the sensor to the variable called the temperature in the ESP32 device that is here. It looks for a data that is being published to the device to modify the publish period. What is the publish period? It's the period between two broadcasts of the temperature. So all in all, this is just a bonus for you guys, is that you can also control your device from your Ubidots account, whether you want to turn it on and off, whether you would like to modify a certain parameter or a certain variable. So it's not just a one-way control, it's a two-way control. You can control your device from your Ubidots and vice versa.